Hey, we have here today a quick integral from the UNSW Integration Bee 2022. This was knockout round 2, problem 2. We have the integral from minus pi over 4 to pi over 4 dx over 1 minus sine x. Okay, and I think what I want to do to start is just multiply this by the conjugate. So in order to multiply by 1, we'll do the same thing in the numerator and denominator. And so when I do this and multiply through, I'm going to have in the numerator, we'll just have this 1 plus sine x. Now when I multiply this together, I'm going to have 1 minus sine squared x, but that's the same thing as cosine squared x. So I'm just going to write my denominator as cosine squared x dx. And then at this point, I'm just going to break this into two integrals, dividing cosine squared x into the numerator. So for the first one, dividing cosine squared x into 1, that's actually just going to be secant squared x. And then for the second one, we'll just use this part, and I think I'm actually just going to leave it the way it is. We could break that into tan times secant, but I'm actually just going to leave it for now. So we've got two very easy integrals here, and we could just integrate, but I'm actually not going to do that. I want to notice that we have the symmetric bounds here. I'm just going to use the property of odd and even functions here to maybe clean this up a little bit. Okay, I just squeezed in these two properties in here over on the right. So for f of x, where f of x is even, when we have the symmetric bounds like this, we can just pull a 2 out front, and we can change our lower bound to 0. And then when we have an odd function, g of x, with symmetric bounds, well then this function is actually just going to be 0. Now for this first function, secant squared, because it's squared, it has to be even. So what I can do is use this property of the even function. We'll bring a 2 out front, and we'll just integrate from 0 to pi over 4 of secant squared x. And then here, cosine squared is even, but sine is odd. So this whole function is going to be odd. And so actually, this whole integral is just going to be 0. And that's just using this property here. So then all I need to do here is just integrate secant squared, but that integral is just going to be tangent of x. I'll bring my 2 out front. We just need to evaluate this from 0 to pi over 4. So now just evaluating tangent at pi over 4, that's just going to be 1. Evaluating tan of 0, that's just 0. So our final solution of this is just going to be 2. Okay, so that's it. We'll stop right there. Thanks everyone for watching. Have a great day.